We have not covered this real number. Polynomial is covered and the pair of linear equation is covered. Right, Harshit?
Yes, ma'am.
Okay. Let's start the discussion of the first chapter, that is real number. Can you see my screen, everyone? Can you see my screen? Yes? Please let me know, anyone from here, Harshit, Galvin. You can see my screen, right?
Yes, ma'am.
Okay, let's continue. So, real number. This terminology is already known to you. The same like the concept of irrational number was there in the previous class, and there only you got to know that all the number which exist in this universe is called real number. Okay, so in reality, whatever number we can think of, whatever number, be it a decimal number, be it a fractional number, be it a non-terminating recurring decimal, be it a terminating decimal number, all the number, be it a whole number, natural number, integer, all the numbers are just real number. So why to specify a name real number? Is there any number which is not real? Yes, there is a number which is not real. Okay, when you will go in higher class, then you will get to know that there are numbers which is not real, and we call that number as a imaginary number. Okay, that's why here we are specifying that we are talking about numbers, and that is real numbers. All the number whatever exists in this universe, what the number which you can write it on this screen, like by using the digits, like from 0 to 9, by using these digits, if you can write this number on your copy, that number is just a real number. Okay, imaginary number which I am talking about, which you are going to understand what exactly is imaginary number, that discussion is there in higher class. Just for information, that imaginary number, whenever we get something in, like when we are having a square root of a negative number, let's say -2, or maybe let's say -1 or -3, inside the square root, whenever we get a negative number, that is not real. Okay, that is not defined in mathematics. One thing we have already discussed, that when we are talking about rational number, it must be in the form of p by q, where q must not be 0. And we always explain to a student that when this denominator, not only for rational number, this denominator should not be 0 anytime in mathematics. Whenever the denominator of a rational term, whenever the denominator is 0, that means it's not defined in mathematics. So two things which we always try to avoid in mathematics, that is denominator should not be 0. Another is inside the square root there must not be a negative number, because that way it it is imaginary. It will just shift to, from real world it will shift to imaginary world. That is called imaginary number. These all are examples of imaginary numbers. Okay, today we are just going to stick to our topic, that is real number. Okay, that's why again and again we will specify the name, that we are talking about real numbers. Okay, now first thing first, you already know what is irrational number, what is rational number. Here few terminologies are there, not only few, like most of the terminology which we will be discussing today in this class, you will think that this is already known to you, why we are discussing it. But yes, the same thing which is already known to you, we will be talking about that in detail over here. Okay, so first concept which we are going to discuss over here is what is composite number, and what is prime number. Yes, anyone from here, please let me know what is composite number. Okay, Ziana, you are saying my last class we stopped at quadratic equations. Yes, Ziana, we realized that real number is still not completed. Is it completed in your batch? Like you are from 10th M1 only. So real number still it's not covered, right? Ziana? Yes, Ziana. Is it covered? Ziana, please let me know, Ziana. Is it covered in your batch real numbers? I remember Omar sir had completed it. Harshit, you was also there in the same batch, no?
No, I think I was not there.
Is it completed or not completed? Okay, Ziana, please let me know. Have you done that? Is it covered that the concept of HCF, LCM, fundamental theorem of arithmetic? Do you know? Can you tell me, Ziana, what is fundamental theorem of arithmetic? Rest of the student, just give me a second, okay? Just let me be clear that here which topic we will be picking at first, okay? In your backup class, whatever we have not done, whatever will be remaining, that I will do in your backup class. Ziana, please let me know. Ziana, what is fundamental theorem of arithmetic? The concept of HCF and LCM, have you done? Ziana, I'm waiting for your response. Yes, so that's why, Ziana, we need to cover this topic at first, because when there will be assessment or exam in your school, at first you will be getting the first chapter. First chapter has to be there, that is real number. Okay, so this chapter if we have not covered, we need to cover it at first, then only we can start doing quadratic equations. I was also about to start quadratic equations, then one of the student reminded me that real numbers still we have not touched this topic, so we need to take this topic. Okay, so that's why I'm taking this topic, so that we can cover it at first, which will be helpful for you in the exam, and then we can start our quadratic equation. Just give me a second, no? No worries, Ziana. It's okay. Like, no, you don't have to say sorry. Okay. If you are feeling something over here, if you want to say anything, please let me know. Okay. We will think about it and we will see that whether it is completed or not completed. No sorry. Okay. Here, you don't have to be sorry for this minor things. Okay. If you want to ask anything, please ask. Okay. So, yes, let's start real numbers. Same for the other student. If you want to say anything over here, please tell me. We will consider it. We will check the matter. Okay, let's start it. So I was talking about composite number. Can you please let me know what is composite number? Anyone from here?
Numbers that have more than two factors.
Yes. Who said? Yes, any
Maha.
number which has more than two factors, that's called composite number. Any number which has more than two factors. Now, what is factors? Suppose I want to write the factors. Suppose I want to write the factors of 12. Or if I want to write the factors of 8. What are the factors of 12? What are the factors of 8? So, factors means, anyone want to say what are factors of 12?
2, 2, 3.
1, 2, 3. Anything else?
4.
Harshit,
Again 2.
can we say 6?
Yes, ma'am.
Can we say 12 as well?
Yes, ma'am.
So factors means we are searching such a number which can divide 12 completely. Such a number which can divide 12 completely. Those numbers are factors of 12. So 1 can divide 12 completely. 2 can also divide 12 completely. Remainder will be 0. 3 can also divide 12 completely. 6 can also divide 12 completely. And the 12 itself, it can divide 12 completely. So apart from 1 and the number itself, there are 3 more factors of 12. Whenever we are listing down the factors, first, like there has to be number 1 and the number itself. Okay. Those are the factors of a given number. Similarly, can you tell me, can anyone say that what is the factor of 8? Factors of 8?
1, 8,
Afnan, Aisha, Galvin.
1, 2, 4.
2, 4,
2, 4, and
1,
what else? 1
1, 1,
and
8,
8 itself, right? These are the factors of 8, right? So composite number means any number having more than two factors. More than two factors. And the example of composite numbers are the number which we have written just now, that is 12 and 8. These are the number which are having more than two factors. When I am saying more than two factor, please do consider this 1 and the number itself. 1 and the number itself. Okay. So whenever we are writing the factors of any number, there 1 and the number itself are the factor of the given number always. And what about prime number? What is prime numbers?
Numbers that have exactly two factors.
That has just two factor, exactly two factor, exactly two factor. That means that means the given number itself and 1. If any number is having exactly two factors, let's say 23, or we can say 19. Okay, these are the number, or we can say 2 as well. Okay, any number, if we will list down the factors of this number 2, 23, 19, there will be only two factors. Okay, two factors. Those numbers are called prime numbers. Okay, so 2, how many factors are there? 1 and 2. These two numbers can divide 2 only. 23, only 1 can divide 23, and 23 itself can divide 23. Okay, similarly 19, 1 can divide 19 completely, and the number itself 19 can divide 19 completely. So these are called prime numbers. Composite number is already known to you. Just a quick recap of that. Prime numbers also known to you. Just a overview of that. Factors, these terminology factors are also known to you. How to list down the factor. You already understand what is the meaning of factors. Factor means like the number which can divide the given number completely. Now what about 1? Is 1 a composite number or it's a prime number?
Ma'am, it is both.
Yes, Harshit, what you said?
Ma'am, it is both.
Okay. You said it is It is neither composite nor prime.
No, I'm saying it is composite and prime.
Oh, you are saying it is both?
Yes, ma'am.
Okay, you are saying it is both. Rest of the student, Aisha, Afnan, Galvin, Ziana, Maha,
It's neither composite or prime.
who said?
Maha.
Okay, Maha, you said it is not composite, not prime.
Yes, ma'am.
Okay, Maha said neither. Neither
Ma'am,
composite
me also
nor
neither.
prime. All right.
Prime.
Ma'am, me
So
also
what are the
neither.
definition of composite number? Now only we have discussed more than two factors, and the definition of prime numbers are just two factors. If we will try writing the factors of one, can you tell me if the factors of one will be?
One only.
Yes.
One fact.
Factors of one will be just one. How we list down the factor? The number which can divide the given number completely. Okay, so one can only divide one, and if there is no other number, then at least two numbers we get, that is one and the number itself. Here we want to list down the factor of one only, so the only factor is one. Is it fulfilling the criteria of composite number? More than two factor? Not at all. Is it fulfilling the criteria of prime number, that is only two factor? No. So we will say that one is neither composite nor prime number. We will, since it is not fulfilling the criteria of composite number and it is not fulfilling the criteria of prime number as well, so one is neither composite nor prime. Okay, now here we are having one theorem, that is fundamental theorem of arithmetic. Let me write down the theorem over here, then we will see what exactly the theorem says. Fundamental theorem of arithmetic. The theorem says that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occurs. This is what the theorem says. Okay, that is fundamental theorem of arithmetic. But when you will read this theorem, it will look like what exactly it's talking about. It will not be that clear. That's how, like, just recall when we were talking about the rational number, it was written in such a way that the number which is in the form of p by q, where p and q are integer and q not equals to 0, those numbers are called rational number, and we just ended up getting confused what exactly is rational number. So we will, once we have seen the example, once we have taken the numbers and we tried to understand the same concept with the help of number, it became so simple. So just like this, when you will read this statement, Maybe it will not be that clear, but let me take one example and let me explain what exactly this fundamental theorem of arithmetic says. This very obvious and basic thing it's talking about, which we have done throughout our educational journey. Okay, so it says that every composite number, you take any composite number. I am going to take a composite number that is 8. Okay, every composite number it says. So randomly we have picked a composite number that is 8. Can be expressed, okay, as a product of prime. So if we will factorize this 8, what are we going to get? Yes, what we will be getting if we will factorize this 8? I'm not talking about write down the factors of 8. Factorize means to break it. Okay,
Ma'am, 2
if we
into
will factorize this 8, what we will be getting? Factorization. Yes, please tell me.
2 cube.
2 cube.
Yeah, we will be getting 2 cube. Perfect. So we will be getting 2 into 2 into 2, or we can say we will be getting 2 cube. So what the statement says, so far we have understood the statement that every composite number, we have taken a composite number, can be expressed. We have expressed it. Okay, we have expressed means we have done the factorization of it. Factorized, I am writing in the bracket. Beside this expressed part, I am writing factorized as a product of primes. Is it so? Have we got the product of primes? 2, 2, 2. Is it prime number? Yes or
Yes.
no?
Yes, ma'am.
It's a prime number. So it says that every composite number can be expressed as a product of primes. Is it so? Let's check for other composite number. If suppose we are taking a composite number 24, if we will factorize this 24, please let me know what are we going to get. Everyone from here, Harshit, Afnan, Aisha, Galvin, Ziana, Maha, Alvina, please factorize this 24 and let me know what are we going to get.
Ma'am, can I say?
Yeah,
Ma'am, 2 cube into
2 raised to cube into 3.
2 raised to the power 3 into 3.
Into 3.
Please check it. Rest of the student, what are you getting?
Yes, ma'am. Same.
Same.
Same, ma'am.
Galvin,
Ma'am, I got the same one.
same. Okay. Okay, everyone is getting the same. So when we have factorized this 24, we got 2 raised to the power 3 into 3, or we can also say we got 2 into 2 into 2 into 3. So what the statement so far, what the statement says, till where we have underlined the statement, every composite number can be expressed as a product of primes. Yes, we are also agreeing with that every composite number, we have taken 2 example and we have checked. So from here we can make the conclusion that yes, composite number can be expressed as a product of prime. And what about the next statement? What does the next statement says? The next statement says that this factorization is unique. Unique means this is unique. No other number can be represented as 2 into 2 into 2. If we are writing 2 into 2 into 2, if we are writing 2 to the power 3, that means it will only generate 8. Yes or no? Can we say that we will multiply 2 into 2 into 2, just 2 into 2 into 2, and it will generate any other number that is not 8? No, that can't happen. Only 8 can be represented as a 2 into 2 into 2. If I'm not making sense, let's read it the whole thing together. Every composite number can be expressed as a product of primes, and this factorization is unique. This factorization is unique and it is only applicable for the number which you have written. If you are getting for 24, if we are getting 2 to the power 3 into 3, no other number will give only this 2 to the power 3 into 3. Whenever we will be having 2 to the power 3 into 3, just this combination, this combination can only generate 24. That's why it says this is unique and this is just for this number. Am I making sense to everyone? This is unique. Are you getting it?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay, it's clear so far. So factorization is unique apart from the order in which the prime factor occurs. So here the statements tries to say that the order doesn't matter. Order doesn't matter. If you will write this as a 3 into 2 to the power 3, order doesn't matter. It will give you 24 only. If this 2 into 2 into 2, if I will just write like the last two I am writing at first and the next two I am writing after that, still it will generate 8 only. If this, suppose we are going to take 12 and we can factorize 12 as a 2 to the power 2 into 3. Okay, so we have represented it in the, like here the product of primes we got, a composite number we have taken, which we have represented as a product of primes. Okay, now this product of primes, here in the statement, the fundamental theorem of arithmetic says that every composite number can be expressed as a product of prime, which is unique. This 2 square into 3 will only generate 12. This 2 square into 3 will not generate any other number. Yes, with the combination of other prime, it will generate other number. But if you will take just 2 square into 3, it will not generate any other number, which is just logical thing. Okay, common sense, obviously, it will not generate any other number. And this is here, order doesn't matter. See the last part, the order in which the prime factor occur. This doesn't matter. Okay, apart from the order in which the prime factor occur. That means it wanna say that even if you will just shuffle it and you will write it as a 3 into 2 square, still it will just generate 12. Now let's summarize the whole statement. It's the definition says that every composite number can be expressed as a product of prime, and this factorization is unique. This factorization is unique. Apart from only the factorization is unique, but the order is not unique. Order can be here and there. The left one can sit right, right one can sit to the left. That is completely okay. The commutative property you must have done, that is when we are having 5 plus 3, even if we will do 3 plus 5, commutative property, this will commute over here, this will commute over here, the result will be same. These two are exactly same. Okay, and it holds for the multiplication also. When we are having 5 into 3, even if we will write 3 into 5, this will commute over here, this will commute over here. Commutative property says that this is completely okay, these two are exactly same. So that's what we are saying in the statement, that every composite number can be expressed as a product of prime, which is unique. The product of the primes which we have used to write the product, that primes are unique. Okay, but the order are not unique. Okay, apart from the order, that means order is not unique. Order can be here and there. It is okay. Is it clear to everyone, the fundamental theorem of arithmetic?
Yes, ma'am.
It's clear. Now let's solve one question. So one of the question is like this. Consider the number 4 to the power n, where n is natural number, check whether there is any value of n for which 4 to the power n ends with the digit 0. Let's see what the question says. We have learned very basic concepts so far, but all of a sudden how this question, that is consider the number 4 to the power n, where n is just a natural number. That means it can be 4 to the power 1, it can be 4 to the power 2, it can be 4 to the power 3, it can be 4 to the power any natural number. N is just a natural number. Okay, check whether there is any value of n. We have to check, is there any value of n for which 4 to the power n ends with a digit 0? Is there any value of n, like 4 to the power 1 is 4, 4 to the power 2 is 16, 4 to the power 3 is 64, 4 to the power 4 is 256? Yeah. Similarly, what is that 4 to the power n? Where our last digit, that means it ends with the digit 0. Okay, what is that n value which we can take, so that when we will find the value, when we will multiply 4 that many times, n times, n can be any natural number, be it 100, be it 200, whatever, n is just a natural number, so that our result, whatever result will be there, that's last digit will be 0. What is that n value which will generate such a result, which that results last digit will be 0? That's what we have to find here. First we need to understand the question properly, then we will talk about how we will approach this question. So let's see, consider the number 4 to the power n. 4 to the power n means we are clear about it, that it can be 4 to the power 1, it can be 4 to the power 2, 4 to the power 3, 4 to the power 4, 4 to the power 100, 4 to the power 200. What is that power? That power we have to find. What is that power which will generate? Is there any n for which 4 to the power n ends with 0? What is that power which will give us the result which ends with 0? Please let me know whether the question is clear to everyone or not.
Yes, ma'am.
Yes, ma'am.
Question is clear. Galvin, Maha, Sumaya, Aisha,
Yes, ma'am.
Harshit, question is clear to everyone. Is it clear?
Yes, ma'am.
So let's try solving it. Okay, let's try finding that n which will generate the result as a 0. Let's see. So 4 to the power n, we can write it as a 4 can be written as a 2 square. And power n is there, it's fine. We can write it like this. And the law of exponent we already know, which says that whenever two different or two same exponents are there, we can do the multiplication of exponent. Do you know that whenever we are having a to the power m into n, it can be written as a to the power m into n? Yes or no? So can we write it here 2 to the power 2n? Yes or no?
Yes, ma'am.
We can write it. Okay, so far what we have done, nothing. We have just applied the law of exponent. We have written 4 in the exponent. We have in the exponent form, that is 4 can be written as a 2 to the power 2, and then we have applied the law of exponent, that is it will be 2 to the power 2n. So from here we realized that 4 can be written as 4 to the power n can be written as 2 to the power 2n. Now this 2n can be 2 to the power since n is natural number, n is natural number, n can be 1, n can be 2, n can be 3, n can be 4, n can be 5, n can be 6, like this. Which natural number? There are infinite natural numbers. It can be any natural number. Okay. So this 4 to the power n became 2 to the power, be it a 2, 2 to the power 4, 2 to the power 5. That means 2 into 2, 2 times 2 into 2 into 2, 3 times 2 into 2 into 2, 4 times 2 into 2 into 2, 5 times, or whatever with the times. It will be 2 into 2 into 2 into 2 into 2, like that. Yes or no? Say yes or no.
Yes, ma'am.
Yes, ma'am.
This is how we can write this 2 to the power 2n. Whatever is the power, that many times 2 will get multiplied with itself, right? If we are having 2 square, it will be 2 into 2. If we are having 2 to the power 3, it will be 2 into 2 into 2. If we are having 2 to the power 4, it will be 2, 2, 2 and 2. If we will be having 2 to the power 5, it will be 1, 2, 3, 4, 5. It depends upon the power of 2. Whatever with the power of 2, that many times 2 will get multiplied. Okay, this much we already understand, that if we have written 2 to the power 2n, that means like 2 will be there. Now when we generate 0, keep it in your mind that we always generate 0 as a last number when we are having in the factorization of the number. If we are having 2 and also we are having 5, then and only then we will be able to generate 0 as a last digit. Let's take few examples. What I am saying that if we are having any number, let's say 20, if we will factorize it, we will be getting 2 square into 5. If we are going to take 30, we will be having 2 into 3 into 5. If we will be taking 40, we will be getting 2 times 4 and 10. That means 2 cube into 5. Okay, so from here I am going to say one very important concept. Okay, just look at the observation. Just see here that here whenever we are having the last digit as a 0, you can take any bigger number, 100 also or 1000 also. Whenever your last digit, or you can take any random number 220 also, or maybe 250 also. Whenever we are having the last digit 0, that means that number's factorization when we will do there, 2 and 5 has to be there. If 2 and 5 is there in the factorization, then it will generate 0 as a last digit. When 2 and 5 is there, here 3 is also there, but that's fine. 2 and 5 has to be there. Then only we will be able to generate 0 as a last digit. Are you getting me? In any number, if 2 and 5 is there, then only we will be able to generate 0 as a last digit. Apart from 2 and 5, if other numbers are also there in the factorization, that is completely fine. But if 2 and 5 is there, then only we will be able to generate 0. If only 2 is there, then we won't be able to generate 0. You take any number, 64 can be written as 2, or 60, don't take 64, let me take 36. Okay, if we will factorize this 36, what we'll be getting? We will be getting 2 square into 3 square. Okay, you can see the end number is not 0. If any numbers end the last number is 0, that number's factorization must have 2 and 5. That will only make 0 at the last. Are you getting me? Yes, Harshit.
Yes, ma'am.
Harshit, Alvina, Aisha, Afnan, Galvin,
Yes,
Maha,
Yes,
Sumaya,
ma'am.
Are you getting it? I am saying that when we will get 0 as a last digit, when the factorization must have 2 and 5. If only 2 is there, you will not get 0. If only 5 is there, you will not get 0. Okay, if you want to check with 5, let's see. Suppose we are having 15. We can write it as a 3 into 5. You can see, obviously, it is not having 0. Okay, so if the last digit is 0 of any number, if you want to tell me any number as an example and to check, please tell me. Anyone? Do you want to take any example where the number is having 0 as a last digit and we will be factorizing that number to check it, whether that number's factorization consists 2 and 5, yes or no? Do you want to take any example? So Maya,
Ma'am, 40.
Alvina, Maha, Harshit, Ziana, Galvin.
Ma'am, 40.
40.
Yes, ma'am.
Okay, Harshit, you are saying let's check for 40. 4040, right?
Yes, ma'am.
Okay, let's factorize 40. What are you getting? Please check it, Harshit. And rest of the student also, please do the factorization. It's a composite number, so please break it. Please express it in the form expressed by taking prime numbers.
Ma'am, 2 cube into 5.
2 cube into 5. Can you see, Harshit? We got the combination of 2 and 5.
Yes, ma'am.
Any other student want to take any larger number to check whether we will be getting 2 and 5? Because whatever I am saying, it can be not true, right? Maybe that is only valid for a few number, but always we will not be getting 2 and 5. I'm talking about the number which is having last digit as a 0. That number's factorization, whenever you will do, you will be getting 2 and 5. If you want to check with any number, please let me know. We will be checking on the screen. Anyone want to check with any other number? 100, 200, 300, 400 or any larger number?
Ma'am, 6,000.
6,000 you are saying?
Yeah.
If you will be taking 6,000, please do the factorization and let me know what are we going to get. 6 can be written as 2 into 3 and 1,000 is there. So I believe 1,000 we can write it as a 10 to the power 3. Okay, if we will break it again, we will be getting 10 to the power 3 can be written as 5 into 2. That's power 3. Rule of exponent says just distribute the exponent. So we will be having 2 into 3. Here 5 will take the power 3 and 2 will also take the power 3. So we will be having 2 to the power 3 is here, 2 to the power 1 is there. Rule of exponent again and again we are applying. A to the power m into a to the power n says a to the power m plus n. So I am going to add the exponent of 2 and 2. So it will be 2 to the power 3 plus 1, that is 4 into 3 into 5 cube. Can you see who said 6,000? Maha, you said?
I said Alvina.
Alvina, you said. Okay. Alvina, can you see that we got the combination of 2 and 5? If any other
Yeah.
number is there, that is fine. Other number is there, doesn't matter. If any other number is there or it's not there, that is completely okay. But if 2 and 5 is there, then only the number will end with 0. Getting my point?
Yes, ma'am.
We have also checked with few numbers. Always it will happen when 2 and 5, that means you understand, no, 2 and 5 is making 10. So any number multiplied with 10 will end with 0. Yes or no? Okay. So from here we can make the conclusion that if we want the last digit as a 0, if we want the ones place as a 0, that means 2 and 5 must be there in the factorization. 2 and 5 must be there in the factorization. But here 2 to the power 2n means what? 2 into 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 2. Whatever with the number of time. Yes or no? Yes or no?
Yes, ma'am.
Yes,
2 to
ma'am.
the power 2n means 2 into 2 into 2 into 2. If n is a natural number, if you are taking n as a 1, if you are taking n as a 1, 2 to the power 2n became 2 to the power 2, that is 2 into 2. If you are taking n as a 2, okay, if you are taking n as a 2, it became 2 to the power 2n became 2 to the power 2 into 2, that means 2 to the power 4. You can see 2 into 2 into 2 into 2. So whatever you are going to take as a n value, any natural number, okay, you will be getting 2 into 2 into 2 into 2, whatever be the number of times. We are not going to get 5. And if we are not going to get 5, then how the last digit or the ones place will come out as a 0? It will not come. Yes or no?
Yes, ma'am.
Yes,
Is it
ma'am.
clear to everyone?
Yes.
So the whole explanation I am going to summarize here. Okay. Consider the number 4 to the power n, where n is a natural number. Check whether there is any value for n for which 4 to the power n ends with the digit 0. We are saying that 4 to the power n can be written as 2 to the power 2 and then power n. By applying the law of exponent, it can be written as a 2 to the power 2n. Okay. Now 2 to the power 2n means 2 into 2 into 2, whatever be the number of times according to the natural value of natural number, like according to this n, taking n as any natural number, it will be just 2 into 2 into 2 into 2. Okay. So since we are just getting 2, we are not getting 5, it will never ever generate last digit as 0. Okay. What about this part? This part was just for seeing the observation, just to see what is the pattern we are getting. So if we will observe this pattern, 4 to the power 1 is 4, 4 to the power 2 is 16, last digit 4, last digit 6, last digit 4, last digit 6. So it will always just follow this pattern. Last digit 4, last digit 6, last digit 4, last digit 6. This is how the pattern will be going on. This was just for understanding. The solution is written on the left hand side of the screen. Okay, these all are the solution. Is it clear to everyone? We can
Yes.
write it in a statement. Since the factorization of 2 to the power 2n will not contain 5, hence 4 to the, for any natural number n, 4 to the power n will not end with digit 0. Here we have to write, since 2 to the power 2n will, just a second, no, just a moment. Will not contain 5, hence for any natural number n. Four to the power n let me write it over here, will not end with 0 as last digit. Okay, 2 to the power n is not containing 5, hence 4 to whatever n we are going to pick as a natural